Lesson 12.5. Use recursive rules with sequences and functions. There's two types of rules. We have the explicit rules, like we've already learned. They give the nth term directly, such as an equals 2 plus 4n. If I wanted to know, say, the 10th term, all I have to do is plug in a 10. And I could say a10 equals 2 plus 4 times 10, which is 42. A recursive rule doesn't give that to you. Each term is found by knowing the previous term, but sometimes they're easier to see. And they're written like a1 equals 6 and an equals an minus 1 plus 4. So what this is saying, you know, our subscript here is 1 less than that one. So that means this is the number that came before, plus 4. So that just means we're taking what we had before and adding 4. So we had a 6 plus 4 makes 10. Plus 4 makes 14. Plus 4 makes 18. Plus 4 makes 22. And so on. You just keep adding 4 to get the next number. But it has to tell you where to start. So we have to start off by knowing what A1 is. So it's actually in two parts. We have the A1 and the AN. And the AN has this an minus 1 portion. For example, let's write the first 5 terms of this recursive rule for the sequence. Well, you can see the A1, the first one's pretty easy because it's told. So A1 is 1. To get the next one, this is the previous number. Well, what was our previous number? 1. So it's our previous number squared plus 1. So we have our previous number, the 1 squared plus 1. So 1 squared plus 1 is 2. Now, that's our previous number. So it'll be, put there, it'll be 2 squared plus 1 for the 3. And now our previous number is 5. So this is, if n is 4, like we are currently at, this would be 4 minus 1 or 3. So this would become A3. A3 was 5. So that's why it's 5 squared plus 1 is 26. A5, well, the previous number was 26. So that goes here for our previous number. So it'll be 26 squared plus 1, or 677. Let's try another one. Well, the A1 is 2. Oh, look at this. They told us A2 also. Now, over here, though, for the AN equals AN minus 2 means 2 back. Minus AN minus 1, so that's 1 back. So 2 back would be the 2, and the 1 back would be the other 2. So it'll be 2 minus 2. It's 2 back minus 1 back. So now for the next one, we have 2 back and 1 back. So it's 2 minus 0. And then for the next one, it's 2 back minus 1 back. So it's 0 minus 2, or negative 2. So when you see n minus 1, that's the previous number. When you see n minus 2, it means you count back 2 numbers. n minus 3, you'd count back 3 numbers. Let's write the rules for arithmetic sequence, where A1 is 15 and D is 5. The explicit rule. The explicit rule is the rule we knew before. That's the AN equals A1 plus n minus 1 times D. That was from lesson 2. Fill in the A1 and the D, distribute, and simplify. Get AN equals 5n plus 10. That one's explicit. If I want to know the 10th term, I plug in a 10, and I find out what it is. Recursive rule, on the other hand, I have to know where I start, so I'm going to have the A1 equals 15. But what is an arithmetic sequence? An arithmetic sequence is that I'm adding 5 to what I had before. So it's adding 5 to my previous number. So it's my previous number plus 5, or plus d. So we have an equals an minus 1 plus d. And of course you have to have what a1 is. So do the same thing for a geometric sequence. Back in lesson 3, we learned that an equals a1 r to the n minus 1. That's the explicit rule. Fill in the a1 and the r, and there's your answer. For the recursive rule, we have this. We have to know where we start, but geometric means I'm multiplying. So I'm multiplying r times the previous number. So in general, it'll be an equals r times an minus 1, and we always have to know what a1 is. That's for geometric sequences. Let's try writing a recursive rule for this. So doesn't appear to be arithmetic, because I'm adding 0 for the first two. Doesn't appear to be geometric, because I'd be multiplying by 1, which doesn't do anything. So it's something else. So I have to look at it and say, what could we be doing? What is 1 plus 1? 2. And 2 times 2 is 4. What's 1 plus 4? 5 times 2 is 10. What's 4 plus 10? 14 times 2 is 28. So I think I've got it. I take two numbers, add them together, and multiply by 2 to get the next one. So here we go. I've got my two numbers, the previous two numbers. This is going back 1 space and going back 2 spaces. Add those together and times by 2. Since I have two numbers here in my thing, I have to start off by giving the first two numbers. So I have a1 and a2. Let's try another one. If it was arithmetic, I'd be adding 1, but then I don't add anything, so it didn't work. If it's geometric, it'd be times 2, but it's not times by 2, so it's something else. How about, what is 1 times 2? 2. What is 2 times 2? 4. What is 2 times 4? 8. So it appears like I'm just multiplying the previous two numbers. So here we go. We just multiply the two numbers. So there's 2 back and 1 back. I multiply the previous two numbers. And since I have two numbers there, I have to give you the first two numbers, a1 and a2.